Okay, you can see all my work right at the beginning here. If you wanted to pause that and get some stuff down, but just listen first here and then try that stuff on your own. They give us, this is the rate at which people enter the line for the escalator. And then this is the 0.7, how fast they exit the line. And then they tell us initially there's 20 people in that line right there. Now, part A just says how many people enter. Enter means that's your R of T. I don't care how many was already there. I don't care how many exited. I just know how many entered in between 0 and 300. So you math 9 that R of T function, and then you're going to get that 270 people. Letter B, though, says how many people are in the line at T equals 300. It says there's always people in the line. So when it says how many total people are in the line, you got to take into account everything. You got to take into account the initial amount. They tell us at T equals 0, there's 20 people in the line to start with. And then we just calculated in between 0 and 300 seconds that 270 people entered that line for the escalator. And then now we got to take out the people that leave the line for the escalator. So like they're going to get on the escalator, right? So they exit the line at a rate of 0.7 people per second. So that's going to be 0.7 people for those 300 seconds there. It's just a constant rate. And then so just calculated work there, going to get 80 people for letter B. Letter C says, what is the first time that there are no people in the line for the escalator? Now, you could do this one of two ways. This black stuff is what went through my mind first. And then I thought about this red stuff just as an alternate way there. So it depends on how your brain works there. But I thought to myself, at T equals 300, we calculated 80 people were in the line. All right. And then it says, see how this says when T is greater than 300, nobody enters the line, which means nobody else is entering the line at that 300. So I have 80 people there. Nobody else is coming in the line, so I'm not adding anybody in, but then we're going to exit the line, so at a rate of 0.7 people per second there. So I started with the 80, and I'm going to subtract out those total number of people as 0.7 people per second, and I want to figure out how many seconds that is. Now, when I solve that equation, I got X says 114.286 number, but see, that was the X on that scenario was the number of seconds after 300, because we already had 300 people pass. All right, we already had 300 seconds pass and we got the 80 people. So if you do the 300 seconds plus the 114, that gives you the total of the 414.286 seconds right there. Another way you could do that is take your total equation for the line, right? So there's your initial amount. This is my total line equation. There's my initial amount. And then we already calculated that 270, that's how many people entered in between 0 and 3. And then we're going to subtract out how many people left the line, and that's what we don't know right here. Now, since this is your total equation, then when I solve this for the T, it should give me that 414 number right there, right? Because I'm actually taking into account the 270, not like the 80 and already subtracting out a bunch of stuff there, okay? So you got your initial amount, total number entered, then subtract how many people are going to leave, and then solve that equation, set that equal to 0, because this is your total line equation, set that equal to 0, and then that's going to give us that 414 right away. Letter D is an absolute minimum problem. It gives you max or min, it gives you a closed interval. This is an absolute max or min, absolute extreme problem where you're going to make an XY chart, and you got to check the endpoints of your interval, and you got to check any critical numbers. Now, this is going to be a good calculator problem for us. If you forgot how to do what I'm talking about here, you need to kind of do a little refresher and rewatch that graphic calculator video that we got at the beginning here for you. But your total equation, you got the initial amount, and then when you integrate the R function in between 0 and some time, that's going to tell you how many people entered in like between 0 and 200 seconds or 0 and 5 or 50 seconds and stuff like that, right? And then that's going to give you how many people entered the line, and you got to subtract out 0.7 people per second right there. And then, so to get your critical numbers, you're going to do the derivative. The derivative of that is 0. The derivative of the integral is just the inside function, and the derivative of that is just a 0.7. And then, so here's the deal. Like, you got to take this equation here, minus 0.7, set that equal to 0. That's too difficult of an equation to solve there. We're not trying to do that. Graph that in the graphing calculator in between 0 and 300. And then let the calculator find the zeros for you. It'll calculate the zeros, and then you get your critical numbers. And then you can now take these numbers here, plug them in for that T there and that T there. So when I rewrote this, I have a green T there and a green T there. And then so I would plug in, they already told us that 0 is going to be 20, and we already know at 300 is going to be 80. We already calculated those guys. I really just got to take this 33 one and the 166 one, plug it in for that t there and that t there. Now you have two options here. You could follow this equation straight up and you could go 20 plus the integral of 0 to 33, close your math 9, and then go minus 0.7 times that 33, and then that'll get you that 3.0803 number. Or what you could do is you can actually squeeze that 0.7 in your, because right now this 0.7t is outside of that integral right there. You would close your math 9 and then do that. Or if you wanted to, since you already have r of t minus 0.7 in your calculator as your y1, you could do the integral from 0 to t, and you could do r minus 0.7. So if you put that 0.7 inside the integral, then the t would just disappear, because if you have r minus 0.7, when you integrate, when you do the derivative of r, you're going to get that r. But think about when you integrate the 0.7, you're going to get the 0.7t. So if you throw that in there, then that t just kind of drops off. But the power of that is like you already have that in your graphing calculator. So you can use that alpha trace and kind of access that, and then just change that number to like a 33 and a 166 there. So whichever way it works in your head, if one of those ways didn't make sense, then just don't worry about it there. But then it says, it says two things here. We got to know the time. And so the lowest y value is that 33. So they ask for both things, that t equals that, and then to the nearest whole number, find the number of people. So the nearest whole number, that was 4 people there. Popcorn.